All right, guys. Again, I'm really sorry about having to do this in videos as opposed to being live with you. I really like being live with you much more, but here we are. All right, so this was the practice that we had where we're naming ionic and covalent compounds all in the same sort of chart here. We got up through the dinitrogen monoxide. So now we're on to the sulfur trioxide. Sulfur trioxide is absolutely a covalent compound. It is a covalent compound because sulfur is a nonmetal, oxygen is a nonmetal, and there are prefixes. So then the lack of a prefix on the sulfur means that there's just one of them. The prefix of tri becomes a subscript of 3. So SO3 is sulfur trioxide. Dinitrogen pentoxide is a covalent compound. Nitrogen and oxygen are nonmetals, and it has prefixes. The prefix of di becomes a subscript of 2, and then the prefix of pent becomes a subscript of 5. PCl3 is a covalent compound because phosphorus and chlorine are both nonmetals. This is phosphorus. The subscript of 1 on the first element doesn't get a prefix. And then that subscript of 3 becomes a prefix of tri. So that is phosphorus trichloride. FeOH2 is an ionic compound. It is ionic because iron is a metal. It's also ionic because hydroxide is a polyatomic ion. You need to know that hydroxide has a -1 charge. So in order to balance that out, there's 2 of them. So it must be iron 2 hydroxide. CuSO4. Oh, this is a compound we're going to deal with in lab a lot on Friday. CuSO4 is an ionic compound because copper is a metal. Sulfate is a polyatomic ion. So the sulfate has a -2 charge, so the charge on the copper has to be +2 in order to balance it out. So that guy is copper 2 sulfate. MOCN4, molybdenum is a metal. Cyanide is a polyatomic ion. This is an ionic compound. Cyanide has a -1 charge. Molybdenum 4 cyanide. Sorry, I'm running out of room there. Molybdenum 4 cyanide. And last but not least, Cl2O7. That is a covalent compound. Chlorine is a nonmetal. Oxygen is a nonmetal. This is dichlorine heptoxide. And remember, if you spelled it heptaoxide, I would be okay with that. It's just a spelling thing. It doesn't matter to me. Other people might matter. I worry when I put these things up on YouTube that I'm going to get roasted for these things, but whatever. Dichlorine heptoxide is the name for that compound. Now, this is looking at what is the percent by mass, and right now we're just talking about AMU. We're going to talk about mass in a different way today, but right now it's just by AMU of phosphorus in diphosphorus pentoxide. So diphosphorus pentoxide has a chemical formula of P2O5. It's a covalent compound. Diphosphorus pentoxide, and then we need to figure out the percent by mass. So first we need to figure out what is the formula weight. The formula weight is when you take things and you add them all together. So we have 2 phosphorus atoms, so that's 2 times 30.97 AMU. And then we also have 5 oxygen atoms, so that's 5 times 16 AMU. That gives us an overall formula weight of 2 times 30.97 plus 5 times 16, 141.94 AMU. That's the total formula weight. And now to figure out the percent by mass of phosphorus, you're going to put how much of that is phosphorus. So 2 times 30.97, 61.94. Divided by, so that's AMU of phosphorus, divided by the 141.94 AMU of the whole thing of the P2O5 times 100 gives you, I keep running my stuff into other things. Let me move this down so it's easier to see. There you go. 61.94, that's the amount that's just phosphorus, divided by 141.94. That's the amount that's total, times 100 gives you a percent phosphorus of 43.6%. All right, let's keep on trucking now. Where is the mouse for this particular computer? Here we go. Okay, So now we're going to continue where we left off before, which is when we were talking about, and we're starting to talk about stoichiometry. And the first thing that we talked about was Avogadro. Avogadro's number allows us to go from atoms, which are microscopic and teeny tiny, to moles, which are macroscopic, something that we can actually see. And remember, I told you it is just a conversion factor. It's a way for us to get from little things to big things, just like a dozen. There's 12 cookies in a dozen cookies. A dozen is just this sort of vaguely made up concept to mean 12 things. A mole is this, it's not made up, but it's this concept that allows us to know that there are 6.02 times 10 to the 23rd things in one of those moles. So let's use it. So this is supposed to be top hat. That's why it's in yellow. If you have 1.74 times 10 to the 24th atoms of carbon, how many moles do you have? Very straightforward dimensional analysis. You have 1.74 times 10 to the 24th atoms of carbon. Again, I'm going to really emphasize that you keep both the unit, in this case it's unit of atoms, and the label, in this case we have carbon. We know that Avogadro tells us that there are 6.02 times 10 to the 23rd atoms of anything, so atoms of carbon, in 1 mole of carbon. One thing I really want to point out, don't abbreviate mole as anything but MOL. We're going to find today and later that there are many, many different M things in chemistry. And if you abbreviate it with like lowercase m, you're going to get confused later on. So whenever you are writing the units for moles, the only appropriate abbreviation is MOL. Okay, so then this is a one-stepper. Double check, make sure that everything cancels. Atoms of carbon cancels with atoms of carbon. So we get 1.74 times 10 to the 24th divided by Avogadro's number, 6.02 times 10 to the 23rd. That gives us 2.89 moles of carbon. Okay, so let's say you wanted to go to the lab and for some reason you wanted to know that you exactly had 1.74 times 10 to the 24th atoms. Well, you would just need to know that you have 2.89 moles. Of course, you can use Avogadro's number sort of upside down too. So this is, 6.02 times 10 to the 23rd is on the bottom. There's no reason that you can't have it on the top. So that kind of question looks like this. How many molecules of water, that's what our answer is going to be in, if we have 1.34 moles of water? So very straightforward dimensional analysis. We have 1.34 moles of water, and every 1 mole of water contains 6.02 times 10 to the 23rd molecules of water. So again, it can be anything. The previous slide we had atoms of something. Here we have molecules of something. It doesn't matter. It's just that conversion. 1 mole contains 6.02 times 10 to the 23rd of anything. So this would be 1.34 times 6.02 times 10 to the 23rd power, 8.07 times 10 to the 23rd molecules. Of water. Okay, so that's Avogadro, microscale to macroscale. And then the last thing we also talked about last class was what does a chemical formula really mean? And I said before that the subscripts are the ratio of atoms, because before we were talking microscale. So for example, I can't remember the example that we looked at. Let's look at water again, because water is a great example. If you look at water on the microscopic level, you have 2 atoms of hydrogen for every 1 atom of oxygen. You can also say that you have 2 atoms of hydrogen for every 1 molecule of water. That's what a chemical formula means. How many atoms there are in ratios to each other, how many atoms there are in the total. That's on the microscopic level. Now, if we scale both sides by Avogadro's number, we get up to the macro scale, and then we're in terms of moles. So now not only are the subscripts are the ratio of the atoms, but they're the ratio of the moles of the atoms. So in this water again, this right here is micro. Let me switch to a different color and I'll start talking about macro. I'll do it in this pink. On the macro scale, it means that there are 2 moles of hydrogen for every 1 mole of oxygen. And that's what the subscripts are. And there's 2 moles of hydrogen for every 1 mole of water. So really straightforward. We're just taking everything at the microscopic, scaling it by Avogadro, and saying that that is what the ratio is in terms of moles as well. So this is on the macroscopic level, something that we can see. Okay, so let's get into a problem. How many moles of lithium ions, that's what we want our answer to be in, moles of lithium ions, are there in 0.68 moles of lithium carbonate? That's where we're going to start. So again, if I were in class with you, I would make you tell me what the chemical formula of lithium carbonate is. Because again, most crucial thing, ionic nomenclature. You can't forget about it. So lithium carbonate, we have 0.68 moles of it. Lithium carbonate is Li2CO3 because lithium has a +1 charge. Carbonate, you just have to memorize, has a -2 charge. So Li2CO3. And if we look at that chemical formula, what that means is that there are 2 moles of lithium ions for every 1 mole of lithium carbonate completely. That subscript of 2 tells you how many there are in one of the whole. So 1 mole of lithium carbonate contains 2 moles of lithium ions. So 0.68 times 2 is 1.36 moles of lithium ion. And again, I'm going to really emphasize this because it is crucial. We have a number, a unit, and a label. Don't lose these things. You need to have numbers, units, and labels in order for all of this stoichiometry to eventually make sense. Okay, so then the next question is asking, well, how many individual lithium ions are there? That should be a clue to you that you're going to need Avogadro. Lithium ions are tiny. That's microscopic. But we have 0.68 moles of something. That's macroscopic. So that's 2 different worldviews, if you will. So that's a sign that you're going to need Avogadro. So I'm going to start this again with the 0.68 moles of lithium carbonate. We know from the chemical formula that every 1 mole of lithium carbonate contains 2 moles of lithium ions. And then Avogadro tells us for every 1 mole of lithium ions, there's 6.02 times 10 to the 23rd lithium ions present. So the first one is the chemical formula, the subscripts, and the second one, second conversion factor is Avogadro. 0.68 times 2 times 6.02 times 10 to the 23rd. 8.19 times 10 to the 23rd. Lithium ions. Okay, that's a review. And now I'm going to start a new video on new topics. So this is review. This is all the stuff that we talked about on Monday. And now I'm going to start a new video. Hopefully this helps. As always, if there are any questions, let me know.